Okay, guys, this is the softball lab. So if you weren't here on Friday of this week, this last week, this is what we did. First of all, we went outside, and your fellow classmates, threw a softball at some angle that we didn't know. They threw it up some angle and some speed that we didn't know. The only thing that I gave them was the distance that it traveled in the X. Let's just say, for the sake of argument here, that it went 30 meters, and the time that it took the ball to go that 30 meters. So I gave them that time, and that was let's say 2.5 seconds. Okay, so I had those two pieces of information. Then they had to find the velocity in the X, the distance in the Y, the height. They had to find the initial velocity in the Y, and then they had to find the time to the top, the time in the air, and the velocity at the beginning. So it should have been blank at a angle. All right. So this is this is everything we have to find. All right, and we are going to start looking for stuff on this next page. So first of all, the time in the air is just however long it was up there. So that was 2.5 seconds. And then the second part was, how long did it take to get to the top? Well, you should recognize by now that if it follows a path like that, this is the midway point. This is the time to the top, is equal to 1/2 the time that it's in the air, because the time it takes to get to the top is the halfway point. So whatever that is whatever the time in the air is, it's half of that. So 2.5 seconds divided by 2 is 1.25 seconds. Okay, so coming back here, we knew that the time in the air is time in the air is 2.5 seconds. Time at the top is 1.25 seconds. All right, now we need to find the velocity in the X. Well, if I'm looking for the velocity in the X, first of all, I need to use the formula Vx equals distance in the X divided by time. So, using this formula, I would do distance in the X is 30, time was 2.5, and if I plug that into a calculator, I get 12 seconds. 12 meters per second. Because we had our distance in the X is 30, that was the total length that it went, and the time that it was in the air was 2.5 seconds. So the distance in the X is this whole distance from start to finish. Alright, and so we have to use the total time in the air and the distance in the X that it traveled. In the end, we get 12 meters per second. So velocity in the X was 12 meters per second. Alright, now we need to find the distance in the Y. How high did it go? Well, if we're looking at the height it went, again, we'll draw this little thing. That's the point where it's at its highest. And the time at that point is equal to the time to the top, which in our case, not top, in our case is 1.25 seconds. So, in order to find the height of an object, we have to use the dy equals formula. dy equals 1/2 ay t squared plus viy t. Now, here's the key thing that we need to look at in this particular case. We do not know what the initial velocity in the y is. So, let's go ahead and fill in the rest of it though. dy equals 1/2 times -10 times 1.25 squared plus something times 1.25. So I've got to figure out what that something is. So that means I need to pause for a second and go to the next one, and we're going to solve for VIY. Well, there's a couple ways we can do this. Alright, the way I'm going to do it in this case is to recognize that in our little path at the top, not only do we use the time to the top, but we also know that in the y direction, the final velocity at that point is 0. So I know that the initial velocity in the y is here. I don't know what it is. Oops. Don't know what it is. It's not 0. And so I'm going to have to solve for it. So what we have to do then is use the only formula that's got VFY and VIY in it, and that is the acceleration in the y equals the final velocity in the y minus the initial velocity in the y divided by the time. So negative 10 is equal to 0 minus VIY divided by 1.25, or 12.5 is equal to VIY. So the initial velocity in the y is 12.5 meters per second. So let's go back to the beginning real quick. We know that this is 12.5 meters per second. Now we need to know the distance in the y. So the distance in the y, now I just plug that in as 12.5, and if I plug this in the calculator, all of this stuff, I get 7.8 meters. Okay, so we get 7.8 meters is the distance in the y. 7.8 meters. Okay, now the last step here, the last thing we need to know is, what is this velocity? So I'm looking for this right here and this angle. How do I find these two things? Well, if you'll remember, we have a component here and a component here. Okay, this is our velocity in the y, this is our velocity in the x. Okay, and so we know that let's just pretend that we have a velocity in the y and a velocity in the x. So there we go, velocity in the x. And what we're going to do is we're going to use our information here and here to solve for this. And you should see that this is a very nice right triangle. So we should be able to use the Pythagorean theorem to find this part, Pythag, and then we're going to use the inverse tangent formula that I gave you to find this part. Alright, so let's go ahead and do that. So we're going to skip back. Remember that the velocity is 12 and 12.5. So we know that v is going to be equal to vx squared plus viy squared, square rooted. It's Pythagorean theorem. So v is equal to the square root of 12 squared plus 12.5 squared. And so we get, if we type this, we get 17.32. And so this is our velocity. But then we also have to find the angle, and the angle is equal to the inverse tangent y over x, which is 12.5 divided by 12. And so if we type this in the calculator, inverse tangent 12.5 divided by 12, we get 46.2 degrees. So, going back to the beginning again, we have a velocity that is 17.3 at an angle of 46.2 degrees. And we're done. Alright, a lot of work, but it's a good problem because it shows us everything. It basically uses all the formulas that we can possibly use. Alright, so the end.